Hello students. So let us continue with conditional probability, and then I will be teaching you one very important concept which we tend to miss out. So let us first do one problem. So the question says a committee of 4 students is selected at a random from a group consisting of 8 boys and 4 girls. So total we have 12 people, we can say, and out of that I am supposed to basically select, or I can say choose 4 out of them. Now the given condition is what? Given that there is at least one girl has to be there in the committee. Now we have to calculate the probability that there are exactly 2 girls in the committee. So what is given? It is given that there should be at least one girl in the committee. Okay, there should be at least one girl. Now the probability that we are supposed to calculate is exactly 2 girls are there in the committee. Exactly, not more, not less, 2. So we have total 4 girls, exactly 2 should be there. So let us start. Let us first write the given words into our event. So let A be the event of choosing, let's say there are at least one girl in the committee, and B that we are choosing exactly 2 girls. So what we are supposed to find, that there should be exactly 2 girls in the committee given that there is at least one girl. Right? So this is the formula that I am supposed to use. Now let's see how we are doing. For getting probability of A, as I told you, it's 1 minus not A. Correct? So it's 1 minus, let's see how do we find this. I am supposed to choose 4 out of how many? 12. That can be done using this. So these many elements will be there in your sample space. Now what I am supposed to choose? I am supposed to choose all 4 as girls. Right? So this will give me probability of choosing all girls. Sorry, probability of choosing no girls, not all girls, it's no girls. A complement means what? Here it is at least one girl should be there. A complement is no girl is there in the committee. That means I am choosing all 4 as boys. So how many boys are there? 8. So it's going to be 8C4. So when you calculate, you will get this. So instead of C, when I say at least one girl, it could be 1 girl, 2 girl, 3 girl or 4 girl. Instead of finding that separately, I am just taking the complement of that. That is no girl is there, and then I am subtracting it from the total probability, that is 1. What is A intersection B? Now understand that the bottom one is pretty much clear. It's 12C4. Okay, I am choosing 4 out of 12. Now A intersection B means what? I need at least one girl, right? That is A, denoted by A, and exactly 2 girls should be there. Now the intersection is what? At least one girl, exactly 2 girls means what? It's exactly 2 girls, right? So out of 4 I am selecting 2, but I need to form a team, or I need to select total 4, but here only 2 are being selected, so the rest I will be selecting from boys, and they both are an event. You're selecting a team together, not separately, so they will be in a product. Okay, so this is what you calculate, you will get, and after that you just have to divide this by this using this formula, and the calculation part is pretty much easy, that can be done. Okay, I hope you understood. Instead of finding probability of at least one girl getting one girl, I am finding 1 minus no girl is being selected. Okay, both means the same. Now let's come to a very very important concept which I have seen students forgetting and not even touching this question or coming through this concept. Okay, now let's see let's understand this concept using a problem. Now consider an experiment of tossing a coin. You're tossing a coin. The first thing you're doing is you're tossing a coin. If the coin shows head, if it comes as head, what you will do is you will toss it again. Okay, but if it shows tail, then you are gonna throw a die. Okay, it depends on the previous one, whether you get head or tail. Then the next thing happens, whether you will be tossing it again or you are gonna roll a die. Next is find the probability of the event. The die shows the number greater than 4. The die should show a number greater than 4. But what is given already? It's given that there is at least one tail. It comes under conditional probability, we can very well say. So I need to find the probability of this given that this thing should happen, should have happened, or I should say. So let's understand using picture. So if I get head, I need to throw it again. So what do you actually get as a sample space? H comma H, first you are getting head, again head. First time you got head, of course, second time you are getting tail. And if you get tail in the first toss itself, then you will be rolling a die. So all these are the options that you will get. So your sample space will be totally this, having 8 elements, right? Now if I ask you what is the probability of getting 2 heads, what you will say from here? Few students will say it's 1 by 8. So probability of getting head and head, you will say it's 1 by 8. Why? Because 1 is there out of 8. But that's absolutely wrong. That happens because we have not learned probability in depth. How you are actually getting the probability of each event is, for the first time when this event is happening, the probability is half. Event of this happening is again, probability of this event happening is again half. And they both are happening together, in the sense they both are giving you one full event, and that's why it's product. So you get 1 by 4. So probability of getting 2 head is actually 1 by 4. Similarly, probability of getting 1 head and a tail is 1 by 4, again half into half. Now when you come to this, how do you do? Similar to the previous one, probability of getting tail is half, but probability of getting 1 is 1/6, and you multiply, you get 1/12. So probability of any of these events, this event, this or this, are 1/12. They are not equally likely. See, probability of head comma head is 1 by 8. It's like fraction. Out of 8 equal parts, I am just picking 1, right? But what's happening here is all of them are not equally likely. That's the problem. When all are equally likely, picking 1 is 1 by 8, but they are not equally likely. See, the probability of getting this is 1/4, whereas for this is 1/12. So this is more likely to happen than this. And that's why we cannot go on and write 1 by 8. Okay. Now let's see what the question was. I need to find the probability that the die shows a number greater than 4, given that you get at least one tail. So A is what? It shows greater than 4, 2 options are there. B, it should show at least one tail. So either this is possible or all these are possible. You find intersection, simple. But now how do you find P of B? For P of B, you have to add all of their probability individually. So this is what you will be adding, and when you add, you will get 3/4. So probability of B is this. Probability of A intersection B is what? Again, you have to add the probability of each element separately. So you get this, and then again you put it in the conditional probability formula, and you will get 2/9. So the concept here that was important was equally likely. When they are equally likely, you can proceed how we used to do earlier. But you have to make sure that the probability of each of the event happening in the sample space is equal, then you proceed in that way. Otherwise, you better find individually. So in this case, you cannot go on and write 1 by 8 or 2 by 8 or just count and just write. You have to find the probability individually. Okay. Let's come to the next question. A die is thrown twice. So whenever an event is happening twice, you are supposed to multiply, not add. Let's just make sure. So die is thrown twice, so number of element in sample space is 6 into 6. So in the first chance, you can get 6 elements, or I can say 6 numbers, different numbers. In the second also 6 different numbers, so it's total 36. If it's happening thrice, you have to do this. If it's happening n times, then this. Same goes for any rolling a die, okay, picking up something from a bag, all those things. Next is what should happen? The sum of the numbers appearing is observed to be 8. Okay, you have rolled 2 die, simultaneously, and you saw that whatever number is coming, the sum of those two numbers is 8. Now what is the conditional probability? Here they have very well mentioned what you are supposed to actually do, that the number 5 has appeared at least once. Okay. So what is given? This was given in the sense you have to understand this has happened already. Now they are asking what is the probability that the number 5 has appeared at least once. When you roll 2 die, there is a chance that 5 may come. First let us verify that. Is there a chance? So what we are trying to do is we are trying to make pairs, keeping in mind the numbers can vary from 1 to 6 and whether the sum of 2 will be 8 or not. So these are all the 5 options that we can have. There is no other option left. Okay. Now in that you can see 5 is occurring in these two, and they are saying at least one, but the part here is it cannot occur more than once. If it occurs more than once, it's 10, because if it comes as 5, 5, the sum is 10. So it will actually occur exactly once only. Okay, if the sum is 8. So let A be the event of getting sum as 8, B be the event of getting 5 at least 1. So B is what I am supposed to find given that the sum is 8. So just apply in the formula simply. B intersection A is what? 2. Out of how many? 36. Sample space, keep in mind. Next is probability of A. You have 5 out of 6. So the answer is 2 by 5. Alright. So I hope this is clear to you. So here we can finish conditional probability. And just don't forget, this was the important concept in today's session. Please go through it, and there are more problems. Such type of problem comes only when something is happening and depending on that you are again doing some other event but two different events. Okay. Alright. Please like, share and subscribe. I will be uploading the next session soon.